Possible flash flooding for the Midwest and Eastern Rockies, winds up to 60 miles per hour, and maybe isolated hail for the Northeast and Eastern Rockies. Good morning, I'm meteorologist Pew. Today is July 30th, 2025. We have 3 marginal risk areas, or a 1 out of 5, in the Northeast, Midwest, Great Lakes region, and also in the Eastern Rockies. And what this entails is that we may see isolated wind gusts up to 60 miles per hour, but also for the Northeast and Eastern Rockies, we may see an isolated hail event. In terms of flash flooding, the Weather Prediction Center has issued a slight risk, or a 2 out of 4, from the Great Lakes to the Midwest and also the Eastern Rockies. For the Great Lakes to the Midwest, we may see rainfall from 1 to 2 inches in isolated places up to 3 inches or greater. And for the Eastern Rockies, we may see half an inch to an inch and maybe 2 inches or greater in isolated places. Okay, so time frame starting with Midwest, because you guys are already seeing the lingering MCS, or mesoscale convective system, which is one big blob that's happening from last night, traveling through Iowa, heading into northern Illinois by early morning. And this MCS is going to travel eastward and persist pretty much all day. So for example, India may see this by like 4 or 5 p.m. Eastern time, and Ohio and Eastern Michigan around 9 p.m. 8 p.m. Eastern time. Also in the Midwest behind the MCS, we may see an additional round of storms around 22Z, which is 5 p.m. Central time. For the Northeast, starting in Maine, you're going to see isolated cells as early as 16Z or 12 p.m. Eastern time. And then everywhere else in the Northeast, especially along the coast, you may see something around 19Z or 3 p.m. Eastern time. And these will also be isolated as well. And for the Eastern Rockies, looks like it's also 19Z, but that's 1 p.m. Mountain time. Looking at the surface, we have a slow moving and pretty weak cold front going all the way from the Northeast to the Great Lakes to the Midwest and even to the Eastern Rockies. All these areas are going to encourage surface lifts to produce these thunderstorms. Looking at the Great Lakes region specifically, this MCS that's going to be traveling eastward, it's going to be following along the cold front, which is going to help produce those surface lifts consistently, which is going to help sustain itself. So in contrast to yesterday, but also similar, instead of a low pressure bringing easterly winds into the Eastern Rockies, we're going to have a high pressure in the north that's going to be doing that. There's still an ample amount of moisture that's going to be traveling into the Eastern Rockies, which should be sufficient enough to produce these thunderstorms. And because in this area, as you go west, the terrain gets higher, and because we have easterly winds, that's going to cause orographic lift, which basically means that the wind is going to be forced going upward because of the terrain, which is going to cause more upward motion and promote these thunderstorms. And looking at 500 millibars and midway through the troposphere, we can see that we have pretty decent shear in the Eastern Rockies, and that's going to help tilt those updrafts and prolong those storms that do develop. Now with yesterday's severe weather event, I mentioned it in the Midwest that these storms are going to produce so much lift that it's going to produce its own shortwave trough, and we can see that still persisting into the Midwest, into the Great Lakes region. And that's still going to do a couple things for us. One is bringing in good shear, which is why these storms have persisted for so long and still will persist all day today. And 2, it's bringing us vorticity, which is adding spin to the updrafts, which is also giving us upward motion. For the Northeast, it's a pretty broad trough that's bringing in pretty good wind shear, but especially in places like Maine where the wind shear is even stronger, this is why there's an isolated hail risk for this area, because the stronger the updrafts, the more it's going to sustain and keep the precipitation afloat. And that's why we may have